So the types of analysis, yesterday we have discussed about the static and dynamic analysis, am I right? Let's say, for example, this is the linear static and this is the non-linear static. We have also discussed the other types of analysis such as geometric nonlinear analysis, material nonlinear analysis. Also, there are other types of analysis. So today we will see that in a nutshell, how do we perform this type of analysis? Okay. So because only theory also, you might not be, end of the day, you might get confused, right? So I'll perform the different types of analysis for you, and you will see that how do we perform these types of analysis. So first one is we will see the linear static. This is the one. Static analysis and linear static. This is what we will see first. So whenever you want to perform this analysis, I'll just go to. So the default type itself is the linear static. I'll just take the perimeter beams. I'll apply certain load. Let's say 2 kilonewton. Let's say here it is commercial building, so it is 3 kilonewton per meter square. Right. So whenever you do the modeling, what happens is by default there are two load cases, correct? So dead load and linear. So can you see this here, linear static? So linear static analysis is by default. Okay, so whenever you are performing the analysis, let's say for example, I'll run the analysis. So when the analysis is run, by default there are two windows. One is this is the floor plan that you are having, and on this side you will see that the 3D view. So in the 3D view, you will see that the deflection shape is there. So let's see the deflection. So all this is the miraculous way of representing is the linear static analysis only. So if I run the analysis, the animation, you will see that the deflection is happening, and from zero situation to the maximum negative situation. So this type of basically analysis is nothing but the linear static only. Linear static. Linear means the original shape and position, it will come back, it will regain the moment you remove the application of the load. So let's say for example this is a slab and you are applying the load, so it will start deflecting. Okay, you remove the load, you remove the sulfate, it will come back to its original position. So that's what we have seen in the analysis animation. All right, so this is the properties and all are there for the linear static. Now let's see that what are the different types of linear static analysis are there. So you are having whatever the things that you are looking into the load patterns, all are linear static only. So what all the things are there? So let's get started. In this case, you will see the linear static, which is dead loads, superimposed load, live load, reducible live load, which is live load reduction as per IS 875 part 2. Okay, so live load reductions, reducible live load, live load reduction parameters, live load reduction combinations. All these things will come into the live load reduction. Roof live load is basically for the American code. Okay, so ACI code will, if you are working for any of the Americans project, that time you might require the roof live load. Otherwise, you don't need to do that. Notional load is basically for the, this particular clause is for NBCC, which is the Canadian code. This clause is there. In Indian code, actually, the notional values and notional code is not there. But still, I would like to tell you what is the notional code. Notional value is something like, from here you will apply 0.002 times values to the x direction. So total amount of dead load is there, and this much percentage, so 2% of the values, if a column is there or a beam is there or a shear wall is there, you are applying the force horizontally. How much percentage? This is 100%. And this much is 2%, right? So this is what actually you will be applying. So if you see the NBCC code and other, see, let us say that you are having the column or a beam or something like this. Imagine that this is your column. Okay, and there is a particular size given. Let's say the size is 300 by 600. And these are the rebars and all. So what happens is I have purposefully drawn this in a little irregular shape. So this is the size in the drawings, but in the reality, you are getting this value as, let's say, 302, and this value as, let's say, 595 something. All right. So what happens is there is a discrepancy in this particular value. And it means that this is not just 300 by 600. There is some kind of incorrectness is there, in the notional case is there. So what happens is whenever such kind of column you are giving here, okay, and you are having a beam, and again the column you are taking it up, again the beam is there, again the column goes up. So what happens is, due to such kind of disturbed or changed values, because 302 might be here, but whereas here it will be 315, or some change will happen. So because of that, some kind of horizontal forces that it may result. That is what actually we are trying to calibrate it here. So that is generally 2%. Okay. So if you guys have worked on the site, you will see that there is a vestige of 2% allowed. Okay. Why? Because as a human error, 2% is something which is okay. I mean, as per the IS standard norms. So that 2% is getting calibrated in the load case, which is called as the notional load combination. Now, if you see in India, this is paramount important. Is there, even if you are carrying out a dead load, live load analysis, you must take 2% force, which is lateral force. That is what actually the NBCC code says. NBCC is a Canadian code. Right, so this is what all about the notional loads. But what is notional load actually? Is it a linear, non-linear case, or what is it? Is it a dynamic load case analysis or something like that? No. Basically, it is linear static only. Okay. So as a matter of fact, we are dealing with the linear static load case only. So whenever you go to any particular load parameters, where is the load parameter? Go to define, and this is the load parameter. Pattern, sorry. Okay, so you go to the define and load patterns. So whatever the patterns that you are defining here, these are necessarily the static load cases. Please understand that. Okay, so whether you are dealing with seismic load case, whether you are dealing with wind load case, whether you are dealing with snow load, construction load, whatever the types of analysis that you guys are doing, here it is just the linear static. Now, this linear static analysis, you can take it further for the non-linearity. How do we take it? You just go to the modify, you go to the define. I'll just show you again. You go to the define, then you go to the load cases, and in the load cases, you just need to go to the modify these load cases. All right, and you modify these load cases from the linear static to the non-linear static, or maybe non-linear construction stage, maybe response spectrum, time history, buckling, hyperstatic. All these types are, by default it is linear static only, but apart from that, many of the non-linear cases will come. Now let's see one by one. Let's take the non-linear static, just non-linear static. What do you mean by that? This is just non-linear, linear static. This one is just linear static. This one is just non-linear static. There is no further non-linearity defined. So this is also one type of analysis. Please understand that. Okay, it is very, very important. Sometimes some people, they say that non-linear means there should be some particular type, whether it is buckling, pushover or something. No, non-linear static itself is a different types of analysis. Okay, so how to define that is you go to this place and instead of the linear, you go to the non-linear. That's all, and just press OK. So are you checking the geometric nonlinearity? There is nothing, no effect is there. If you are giving from here as a p delta, then it will become a p delta analysis. So somebody will say that how can you perform the nonlinear static analysis? So it is just none here. So this is the non. You just press OK, OK, and run the analysis. This is nonlinear static. Now somebody will ask you that how to perform the nonlinear, just nonlinear p delta analysis. How to define that? So from here you go to the p delta. This is nonlinear static with the p delta analysis. Alright, so this is purely the p delta. Apart from this also, there is one more type of p delta is there. What is that? You go here and you define the p delta cases. Now let's say, for example, 1 minute. P delta options. Can you see that here? P delta. Now, what is this P delta options all about? We call it as P delta preset parameters. So there is an automation method in which you will define this as a P delta. By default, we will generally take its iterative based on the loads, not based on the mass. So we'll go for generally this particular case. You know that it would be 1.5 times dead load plus. So at this place, what are you going to define? See, you are going to define 1.5 times dead load or 1.5 times dead load, 1.2 times dead load plus 1.2 times live load, whichever is critical. And if you ask me 1.5 times dead load, this would be the most critical, the load case or a combination for the preset P delta parameter that you might be experiencing. All right. So how from where you got this? Is it the code says this? No. Is it then where you got this? So it is basically the ETABS analysis manual you need to read. What you need to read is ETABS or CSI, we call it as ETABS analysis manual. In ETABS analysis manual states that if you are having whatever the lateral forces, like let's say for example 1.5 times dead load plus 1.5 times earthquake load you are having, then you are having 1.2 times dead load plus 1.2 times live load plus 1.2 times earthquake load. It is plus or minus or something that we will see it later on, but necessarily the earthquake load is 1.2 times. Another combination is 0.9 times dead load plus 1.5 times earthquake load. So what actually the code is trying to tell you over here is whatever your lateral cases are there, these lateral cases are there, you can replace these lateral cases to the P delta, because P delta is necessarily the horizontal component of the vertical elements or the vertical loads. What do you mean by that? It is just like that you are having, let's say, the column here. Okay, and there is a deflection. Okay, and every place you will see that there is some kind of delta effect is there. Right, some kind of delta effect is there. This is basically, your delta. This is, let's say, the delta 1. This is delta 2. This is delta 3. This is delta 4. So whatever the forces that you, let's say this is P1. This is P2. This one is P3. And this one is, let's say, P4. So P1 into delta 1 will be the bending moment acting on it. P2 into delta 2 will be the bending moment acting on it. P3 into delta 3, this will be the second order bending moment. What this particular bending moment is called as is a second order bending moment. Okay, so I will just take this print screen and paste it here across. So it is basically geometric nonlinear second order analysis. So that's the reason this P delta analysis is also known as geometric nonlinear second order analysis. Why second order? Because this is the first phase of the column. This is straight, right? This column is straight over here. This column is changing its position from here to here like this. So why not third order? Yes, there will be third order also. So this bending moment or this deflection might change because of P1 delta 1. It might change somewhere here. Again, it might change somewhere else. So where to stop? This is what the place to stop. So this we call it as the convergence factor. Please stop the analysis if the convergence is less than 0.0001. Alright. So this is what actually the P delta, which is the geometric nonlinear analysis. Alright. Now just look at me. Imagine that this is a column. Okay. And you are giving some kind of force on this. So because of that, this particular column is trying to change this position, like this. Okay. But the self-weight of the column is there. Vertical force of the column is also there, right? Because of that, this particular bending moment that may occur. Okay. So this by default, there is a P into delta. Okay, because of this delta, again this will be the second order delta, then third order delta, then fourth order delta, then fifth order delta, like that. So between the two orders, if the distance between that distance, if it is less than this particular distance over here, which is 0.0001, then the P delta analysis one must stop. Why? Because the further changes will be negligible. Alright, it means that, let's say for example, you are having 69 percentage. Somebody will say 69.2358946832 ... So other parts are not important, right? The percentage that you got you can say 69% or 69.2%. So other values are not important. So somewhere you need to stop it. So somewhere, which place is what you are going to determine this from here. Alright. So this is the second order types of analysis. Now I'll just paste this figure actually and MS Paint so that okay. So have you understood the p-delta analysis today? Okay. Now, when to do this, perform this p-delta analysis? Whether basically this analysis is paramount importance, why it is to be done, where it is to be done, all these parameters that might be there in your mind. Okay, I'll just paste this figure over here. Anyway, later on I'll just do that editing. So we have seen the linear static analysis from this place. We have also seen the linear static non-linear analysis with the p delta. Now, when the p delta is very important, why it is to be done, how it has to be done. So this experience, I want you to have it by doing the p delta analysis. Okay, what is to be done? It's very simple. You just need to go to the define preset p delta analysis, preset p delta options, and from here you just need to press a button. 3 clicks, 3 to 4 clicks are there. Believe me, all the types of analysis which I am going to explain or which we are explaining in this chart, it is hardly 4-5 clicks, operational level. You can ask the doubts how to perform this analysis in your chat box also, no problem. If you are facing problem, that's how to perform the p delta and all, what are the issues are there and all. You please try from your own side that how to do that. What is basically the load basis. So I have told you that you need to take 1.5 times dead load or 1.2 times dead load plus 1.2 times live load and just say okay, run the analysis. The p delta analysis will be run. I'm running this. So if you see this at this place, you are running the analysis. You are also running, see here, p delta analysis. So first iteration, second iterations, all the iterations will be done, and the preset p delta analysis would be done right in front of it. It will take hardly few seconds more, but it will perform the analysis. What it is performing? It is just performing in such a way that, let's say for example, here this column is moving in this direction. So this P into this delta. So that way, the bending of this column, it is changing. That is the P delta analysis, effect of the P delta analysis that you are trying to observe it at every particular node here. Why I'm telling you like this? Because you will be seeing these nodes. You will be seeing these pictures whenever you are performing the analysis. All right. Just a minute. Okay. So, what are the other types of analysis are there, and how do we perform this? So the other types of analysis are, like we are having the buckling analysis, pushover analysis, creep analysis, shrinkage analysis, and other types of analysis. So we'll see few of the analysis, but we will not be taking all the types of analysis in the basic workshop. All right, so let's get started with the one or two types of analysis. We have seen the P delta, so we will see the P delta with construction sequence. All right, so what do you mean by how to do the construction sequence analysis and all? So let's get started with that. So let's say, for example, if you want to perform the construction sequence analysis, you just need to go to the define and go to the auto construction sequence case. Okay, so at this place, I'll just unlock the model. So you go to the define and auto construction sequence case. Here, you just need to click this case is active. And at this place, you can go to the geometric nonlinearity option as P delta. And give the auto construction sequence load case here and just say okay. So when you run the analysis, now I'm running the analysis. So it will do the initial order analysis, and later on it will do the construction sequence analysis as well. All right. So we'll just see the type of analysis, how it is done. So let's say, for example, here I'll go to the 3D, and in the 3D I'll just go to the construction sequence, auto construction sequence here. So this is the first step. This is the second step. This is the third step. This is the fourth step. So like that, auto construction sequence load case analysis will be performed. So one above the other. See, every floor every entire building you cannot construct at one go. Am I right? So what you will do is one floor with the columns here. You will add the columns above the slab. You'll put one more slab above this. Like that, you will go on casting like one slab, then the second slab, then the third slab, and that's how the cumulative effect of that on the columns and beams. Not one go. So that is what actually the construction sequence analysis. All right. So you will be performing these varied variety of analysis, and when to use what type of analysis. See, to be very honest, many people during the college days, including myself, to be very honest, we have never came across varied variety of analysis. It is just like we have studied only the linear static and other types of analysis. We have just heard about it, but we didn't get a chance in the college days actually to go through the different type of analysis, apply the factors, when to apply, why to apply, how to apply, after performing, how to check, all these things. So during this series, actually, I'll be briefing most of the analysis types. All right. So one day we'll take 2-3 types. Again, we'll take 2-3 types, and we will slowly, with the baby step, we will move ahead. Today we have seen the linear static. Second thing is we have seen just the non-linear analysis. Third thing is we have seen the P delta analysis, and the fourth thing we have seen the construction sequence analysis. We are not finished it, all the types, but when to perform this analysis, how to perform this. Okay, we will see in detail actually what are the implications, what are the effects are there. Okay, so I'll take certain questions now, because analysis is one of the interesting topic and very, very, very important topic. Okay, so that's why I'll go a little slow, but I will make sure that everybody understands. I'll take certain questions from the audience. 1 minute, I'll just I will allow you to unmute yourself. So if you want to ask certain questions, please ask.
Hello, sir.
Hello.
Yes, sir.
Yes.
Sir, I was asking in each and
Please
every
on
project we
your
should.
camera so that we can see yourself. Thank you. Yes.
Sir, I was asking in each and every project we should do auto sequence, auto construction sequence analysis.
No, no. First of all, you must understand how to perform the analysis. Okay. Imagine that you are a doctor, you are giving injections unnecessarily to many, many people. And you will see that it is not important after performing the different types of analysis to many structures. You will see that it is not important. Why we have to do it? There is hardly any change. Then over the period of time, you will see that we can ignore this. But at the beginning, you should do the analysis. You should perform the analysis. After performing, you will see that you uh, you consider that all these template projects as your patients. Apply all sorts of injections. Don't worry, the building will not fall down. That is my guarantee to you. Okay, but when you perform many types of analysis, and you study the behavior of that, and over the period of time you will understand this is not important or this is important. Hmm? How to check that whether it is performing or not? You check the axial forces in the columns, you check the bending moments in the columns, you apply that dead load, and you apply dead load with p delta. Okay, you create dead load with auto construction sequence case. So in the dead load only you are having dead load analysis, non-linear dead load analysis, non-linear with the p delta analysis, non-linear with the construction sequence analysis. So self study, I would like to suggest you, there are two types of studies actually. If you remember in the very my workshops also I have told you many times. Here also I will tell you there are two types of visions I want you guys to develop. Okay, two eyes are there, right? Okay, the third eye is also in Hindu mythology we call it as third eye, the conscious eye. Conscious eye means you are aware what is going on. All right. So in the deep meditation we do the samtratak mantra and all actually here. It is just to respect basically this sthana. Means what? You are aware what is happening. Right? So similarly, I would like to tell you that you analyze it, you understand how the behavior is working. Okay, you understand the macro analysis, the macro behavior of this. What is the deflection? What are the stresses? What are the bending moments and all? Once you do that, you perform other types of analysis. After performing other types of analysis, you will see the difference. Okay, how to check the difference also, I would like to show you right here. See, let's say for example, this is the linear static. What I'll do is, in the auto construction sequence case only, I will apply construction sequence with just the dead load analysis. And I will create a different load case type. So this is the one, auto construction. This is, I will give the dead with auto construction. Why? Because I have given only dead load here, right? So how many cases you are having? Dead, auto sequence, and this one. So here also I'll give the same name. Okay. So these are the types of analysis. Now, similar to this, actually, I can give one more. I'll copy this. I'll add a copy of this. And I'll give here dead as non-linear. And instead of static linear, I'll go to the non-linear. Just say, okay, run the analysis. Don't apply P delta. Then you apply P delta also here. And then you give P delta also. So, this is without P delta, you add one with P delta. So in the dead load only, you are having dead only, the auto sequence, without P delta, with P delta. Run the analysis, see yourself. See, seeing is believing. Do you agree? If you run the analysis and you see that, and you can give one more window also, add one more window here. So this is dead load analysis, this is dead load auto sequence analysis. This is another types of analysis. So what I'm trying to tell you is, I want you guys to develop this third eye vision. Okay, and believe me, this is the literally the master study. What we are calling it as, you will become master only if you develop this vision. It is very easy. If I take another 2-3 sessions, I can give you all the types of analysis things, but it will be just a lecture for you guys. I don't want to give you just the lecture. I want you to give the experiential knowledge that will possess with you. If you remember, in the college days, you have learned about many theories. Do you agree? Slope and deflection theory, stiffness matrix. Let's say, for example, Sushant, if I gave you the one example with the 4x4 matrix solving example, would you able to solve immediately? Tell me honestly. I'm not saying you are not qualified. Even I will be failed miserably. Even better than, I mean, more than you, I will fail, because you are in touch with certain subjects even today. Okay, why? Because this is our brain basically. Unwanted, unrequired knowledge, it will automatically will get evaporated. Okay, the moment you apply certain experiential knowledge, it will go to the subtle level, it will go to the deeper level. Addition, subtraction, you will not fail because you have done that in the supermarket or some places. You have experienced it. All right, so I want you guys to have that kind of experiential knowledge. All right, so today's task is, please perform different types of analysis. You create a small report, PPT or anything. Dead load analysis, notional value also I have shown you, NBCC code. Understand that what NBCC code is. Okay, and these are the topics actually which will make you completely different student out of the competition box. Any other question anybody want to ask? Yes. So no questions. I thought many questions will come, that's why I given some more time.
Hello, sir.
Yes.
Sir, actually, in some cases, what we find is we're getting reinforcement more in the higher stories, in the columns, than in the lower stories. So why will this happen?
Correct, because the if you see the graph, actually, 1 minute. If you see the graph of the column design, column design is always like an interaction diagram design, right? Let's say, for example, let's say this is the interaction diagram, right? What we call this as a P. This is basically the P. Okay, and other part is bending moment. So from here, if the bending moment is 0, this is the neutral axis. What is this? This is the neutral axis. This is 0 P and 0 bending moment. Okay, and this is the graph. What this graph is all about, that this is nothing but the P, whereas this is nothing but the positive bending moment. What is this? Positive bending moment. This is negative bending moment. The moment you will see that there is a huge amount of bending moment, you will see that the capacity of the P will get reduced. This is basically in 2-dimensional. If you see in ETABS, you will see that in the 3-dimensional also. It means, let's take some figures. If 100 kilonewton or 1000 kilonewton is the capacity in P, you will see that since it is in this axis, bending moment will be 0 only. Any other bending moment, it can't take it. But if you see that this particular, you can see the value is increasing. Like this, the value will get increased. The moment you will see that the negative or positive bending moment value is getting increased, the P capacity is getting reduced. Imagine that this is the bending moment that you are having. The P value will not be 1000 kilonewton. It will be hardly some less than 500 kilonewton. It means that, let's say, for example, your column is there like this. The column is going on the upper levels. Okay. So this is the column. And let's say this is the foundation that you are having. And these are the floor beams connected to this column. So as you go down, you will see that there is a P value here. It is going more. It is going even more. This is the value of axial force. All right. But at the top level, you are having a lateral force which is very higher. So you will see that the bending moment value that you are having here, it is more. P value is less, but the bending value is more. The P value is less, but the bending value is more. That's the reason at the upper level also you will see that the reinforcement requirement is higher. But you cannot give the higher rebars on the top, so you need to take it from the bottom only.
So we have to consider the maximum from the entire structure and then consider that.
Yeah, you see, you can apply, let's say, for example, 16 mm bar is there. This is 16 mm bar. You can lap the bar which is a little on the higher side, which is 20 mm. This is 16 mm. 16 on the 16 mm you can lap the 20 mm, but you cannot lap the 25 mm. So one bar up only on this bar, one diameter up only you can do that. But on 12 mm, 16 mm becomes little difficult. So these are practical things. So that's the reason, if you remember, I told you there are 3 types of pressures are there on the site. One is site related conditions is there. Based on that, you need to change the design. Second thing is you require, this is the requirement actually. So requirement based will be there. Design requirement. And the third thing is code based. Sometimes site requirement will be there. That's why you have to increase the rebar. As you said rightly, you require higher rebars on the top. Even if you don't require these rebars here, you have to give this. Why? Because it is site related pressure. On the site, design wise it is okay. Code wise also it is okay. But site wise it is not okay. You have to be based on the site. Alright. So 3 types of pressures are there. You need to manage all the 3 types. See why the structural engineer at the very first place fails many a times. It is because of that only. That you sometimes you deal with only design only, but you ignore the site related parameters. That is a big failure. That you should not do it. So first you master the design and then you see the site related parameters also. You see the code related parameters also. Site congestion should not happen. So all these things you require. So if you remember, just today we have seen the different types of analysis. For different types of analysis, you will see that different types of P value. This value will be different. Now this value is basically for the dead load. This value will be, for earthquake load, for wind load, many other loads actually will be there. So different P value will be there and different positive bending moment and negative bending moment values will be there. So in the E-tabs, now I'll just show you, go back to the E-tabs, or maybe in any software for that matter. I'll run the analysis. And I will check the values, that which values that it is governing. And based on the values, I'll take a conscious call. Now it is running the auto construction sequence also. And P delta also. Now let's say from here I'll go to the axial forces. So these are the axial forces. If you see the axial forces, this is 240 kilonewton. Whereas if you go down, what is the figure here? It is double, 900 and something. If you are having trouble, just right click it. From here you will get it. Now this is just the axial forces. But what about the bending moment? This is the bending moment. So bending moment here is 0 only because it is hinge support here. But the bending moment here is more. So that exactly I wanted to show you. That even if the bending moment is 0, the P value will be highest. Or if the bending moment value is more, how much is the P value that you are getting? So based on that, actually it will give you the PT percentage. All right. Any
Thank you,
other
sir.
question?
Yep.
Yes, sir. One question.
Yes.
You said that on 16 mm bar, we can lap 20 mm bar.
Hmm.
Now, suppose my requirement at the top load is the 25 mm bar.
Hmm.
So, can I start the slapping this bar
So one floor below only you need to change bar diameter from 16 mm to 20 mm. So
and
that
on
20 you can go for 25 mm.
25. Okay. Yeah.
So it
that
is
is a practical application.
that is the practical application. So that's
Okay,
what
okay.
the site means. The practical application is what you need
Right,
to think.
right.
Correct.
Okay. Because I had to face this kind of problems at some of the sites.
Huh.
Good. Today you just clarified this.
Yeah.
Yeah. Right, sir.
Okay. Any other question that anybody want to ask?
Sir, if I'm getting 0.8% rebar percentage in the entire column, does it mean it is economical, or does it mean it the size is so much?
No. Sometimes actually what happens is the size is what you can reduce the size in that case.
Okay.
So I will give you the example here. Let's say, for example, here. So here, this is what is this is the capacity curve. 1 minute. This is what is this? This is the capacity curve. Do you agree? This is a capacity curve. So your forces is only this much. So why you want to have the capacity this much? You can deal with the capacity this much only, no? So you can reduce the size of the column, you can reduce the rebars also, so that it becomes economical.
Okay, sir. And sir, as we go
So you will design is based on 0.8% of this value rather than this big value. So let's say, for example, your size is 800 by 1000 is the size of the column. So 2% of that, 0.8% of that is what you require. Why? Because this size is huge. You might require 300 by 600. In that 0.8% of that is required. So if you calculate 0.8% of this value, it will be very less number of rebars. Why 0.8? Because this is the codal requirement. That's what I'm saying, the requirement of the code. So these are the three pressures are there on the structural engineer's mind. Based on that, he need to take a call that what reinforcement that you need to give. So just few minutes back, Mr. Tushar has said that you require the 20 mm bar at the lower level, even if it is not required. Why? Because on the top floor you require 25 mm. Okay, so that actually, if you are there as a site engineer, you cannot take that call. But since you are knowing that these design aspects, you can take this sensible call right away. Understood? So this is what I wanted to say. So 0.8% only you are getting, you reduce the size. It might be the situation that in this also you require 0.8 only, or maybe 1%, but still this is economical. Because shuttering value will be reduced, shuttering area will be reduced, concrete volume will be reduced, and 1% of this value and 0.8% of this value, there is a huge difference.
Yes.
So that is what is we call it as the value engineering. Okay, sometime later I'll take a special session on this value engineering. So don't worry
So
about
one
it.
last question. One question. Sir, as we go up in the building, sometimes we reduce the size of the columns for the value engineering. So is there any criteria that we can reduce the size of the column this number?
So that is also another site related parameter. So let's say on 800 by 1 meter, on the top you give 300 by 600 only. So what will happen? There will be the story stiffness you are changing hugely. So in that case, if the story stiffness is changing that with that much percentage, you might apply 2.5 times the lateral force. That should not happen. So in that case, I would suggest that at the first place, this column size only I will reduce it so that it will not be considered as a soft story. So the reduction of the column, how much it should be? It should be like 25 mm from both the sides. So maximum 50 mm is what actually I would suggest. That if this is the width or the length of the column is there, you can reduce 50 mm here, again 50 mm here.
Okay.
Also, it is advisable to reduce the width of the column first, then the depth of the column. Because width of the column will decide the carpet area. What do you mean by that? Let's say, for example, imagine that this is, your wall, block wall. On the block wall, you have to give the column, right? So
Yes,
if the column size is this much, what will happen is this particular portion, is getting eaten from the carpet area. Do you agree?
Yes.
This area is getting eaten from the carpet area. So I don't want that to happen. So what I'll do is I will reduce this size as less as possible. So instead of this like this, what I will try to do is I will try to give the column size as this much. This is more economical. Why? Because my this carpet area I am getting more. In the place like Mumbai, Delhi and all, carpet area costing is quite high. So this area, my customer is going to get it more. Whereas I am increasing the size here, that doesn't matter. Understood? So these are certain concepts about the value engineering. We will look into these concepts a little later on. But these are very, very important. Based on that, the credibility or the kind of structural consultants, behavior, many things actually are dependent. All right. So any other question?
Sir?
Yes.
As you said, we going to use the diameter of the bar on upper stories. What will will there be any eccentricity problem?
No, आपका आवाज थोड़ा कट. Can you just type this in the chat box?
Yeah.
Yeah. Any other question? Anybody?
Hello, sir.
Yes.
Yeah. Sir, is there any criteria regarding P delta, whether we should go for the P delta analysis or not? I think in American code, provision.
See, if the delta is 0, P delta is 0. Do you agree? If the delta means the first deflection is 0, there is no deflection. So P into delta, P into 0 is 0. Right? So you just need to make sure that your delta values are less. If your delta values are more, the P delta analysis will become, more problem for the structure. So you need to see the vertical deflection. How much is the vertical force, and based on the vertical force, how much is the lateral deflection? Understood. Now, to give you the demo, because I think this may not be possible for each one of you to understand. So I'll give you a small demo. Like this is the column. How much is the lateral deflection? Can you read it out? UX and UI. It is 7.66 into 10 raised to minus 10. Do you agree? Yes or no? See, UZ is minus 1.1 mm. Whereas at this point, you can see the screen, right? Everyone? Okay. So, see, at every point, you will see the UX, UI, UZ, which is translational displacements. RX, RY, RZ is the rotation, okay, in radians. So, UX, UI is basically in the X direction and in the Y direction. Correct? You are not bothered much on the Z direction because it is axial shortening. That value is also very less, 1.1 mm. But if you see the lateral deflection, how much it is? Minus 7.66 e to the power minus 10. So it is 0 only. Then why do you do the P delta? Understood? Because this into P, if you multiply, that is also, it will not add 1 kilonewton meter bending moment. Then why the hell you are giving that injection? That is the point. But every time this sophisticated, very, very equilibrium building will not come, correct? No. Sometimes you will have problems like, the Reliance Mall that you guys have developed. So that time you need to investigate that whether he is going to give this injection or that injection. Whether you need to give this analysis or that analysis. Understood?
Yeah.
Okay. Any other question, anybody? I think somebody is raising the hand. I don't know who is it. Yeah. Okay. So thank you very much. We'll see you next time. Okay. Are you enjoying these sessions, everybody?
Yes.
Yes,
sir.
sir.
Is it really helpful?
Yes,
Yeah,
sir.
yeah, very much helpful.
Okay, good. See, believe me, everybody need to do the regular practice. Like today we have seen the P delta, linear static, construction sequence. Do the small model. Don't invest a lot of time in the modeling aspect. It is waste. Okay. Why? Because you are focusing only on the various different types of analysis aspect. So you need to be tricky in understanding this. The moment you understood like how to do the quick model and get these types of analysis, the next phase.
अर्निंग चाहिए तो लर्निंग करनी पड़ेगी, ज्यादा अर्निंग चाहिए तो ज्यादा लर्निंग करनी पड़ेगी। और लर्निंग के लिए ई कंस्ट्रक्ट मास्टर स्टडी ऑन जॉब प्रोग्राम्स है ना। अगर आप सिविल इंजीनियर है और अगर आपको कोर टेक्निकल प्लेसमेंट चाहिए सिविल इंडस्ट्री में, तो ई कंस्ट्रक्ट के ऑन जॉब फुल टाइम ऑनलाइन और ऑफलाइन ट्रेनिंग प्रोग्राम्स को ज्वाइन करके आप सिविल इंडस्ट्री में अपना पहला कदम रख सकते हैं। तो आज ही ज्वाइन कीजिए मास्टर स्टडी लर्निंग प्रोग्राम्स एट ई कंस्ट्रक्ट।